Today we're going to be taking a look at critical path analysis. Now, what does this mean? Basically, if we have a coal record, we are asking how late can we dig every other record so that this coal record will still be dug at the same date? Meaning that everything above that coal record will be its critical path. Any of our dependencies, any way that they may make some other records wait, that will be our critical path. If we have a branching path, meaning there are two records, both that need to be done, then whichever one takes a longer time will become the critical path in that respect. So let's actually jump into a model here and see what that looks like. Today we're going to be looking at some path analysis to see where we are digging too soon, or perhaps where we have some critical paths that might cause us problems if anything breaks down. Very first, let's just take a look at what is going on in this model. I have a fairly simple model with a simple excavator that is digging this down bench by bench. These are just the first 5 blocks in a single strip here. Some free dig at the top, some excavator, and then the darker gray areas are coal. Now today this is going to need a script, which means we are going to grab it from the unsupported utilities and the script downloader. If you don't see this spanner up here, you can always come across to File, Settings, All Settings, and then search for unsupported and just turn both of these to true. So jumping back in, if you click the spanner, you can come down to the script downloader. And the one that we're looking for today is actually a scheduling engine script called the critical path analysis. If I hit OK and accept, that will bring this script into our model. The only thing I have to do to actually make sure that this works is come in and select it as a scheduling engine script, hence why it's under the schedule engine folder. Now, what will this script actually do? Well, quite simply, when we run our model, if I take a look at my deposit table, we have a folder down the bottom called CPA. Now for each area in my model, it will get written dates from this script that are the critical path analysis. Now what we can actually do with those dates is we can compare them to a post-scheduled task. Now this just actually writes the exact dates that these were mined. And we can go ahead and we can take a look at the difference in those numbers. Now I have that here in a folder called difference. And this is simply a measurement of hours between these two dates. Now I will bring that expression up on the screen just here. So if you do want this to be hours, you can represent it with total hours. There are other few total commands. You have days, milliseconds, minutes, and seconds. You can set any of those up so that they do actually come through. Now we can see these numbers are filtering through, and what we can actually go ahead and do with that is in our animation, we can come in and we can set up some solid colors. Now I have one here that is just the CPA difference, so it's just going and looking at that field, and it's filtering them from green to red based on that. Now we can see this is just for blasted excavator, so I am going to select this color, and then I'm just going to filter out everything except our blasted excavator and our coal. So we can see currently up the top, it turns more to red the further away from the coal, meaning that these areas here just above the coal happen very close to the day that the critical path would have to happen. Now, the only dependencies we have in this model are a dig top down, a disabled cone, and then a process dependency, meaning anything that has to happen for this coal to be mined is directly above it. And that's why we can see, because our excavator is mining these down bench by bench, as it gets closer, each one of these is as close to as late as possible before this coal can be dug. However, as we get further up, obviously we could change this equipment's path so that it dug all of this before it did any of this. So if we do want to see that, we can jump across, and instead of our order being bench, if I actually just take this out, and now we take a look, everything will be green because our equipment is just digging from top to bottom. And for that reason, everything becomes green. Now, very quickly, if I just come into my equipment and I let it dig bench 70 to 120 of block 3 before it does anything else here, we should see that those benches now turn red because they get dug right at the start. However, they don't need to be dug for a long time because we don't actually get down to the coal. So all of this works backwards from the date that the coal is actually mined. Once my equipment reaches this exact point where it is mining this coal, it can then say, okay, how long does the task on top of this actually take? Well, at a very as late as possible sense, I'm going to take this date that I currently have, add on the time for that task to be completed, and that is as late as that task could be completed. Now we're going to take a look at one more quick example here, just with this cone dependency enabled. Now if I rerun this, we're going to see some slightly different results. Still we're digging over in that area first, and then we come down, and then as that cone dependency starts to kick in and we're no longer just mining that entire area, we can see the differences in this change. Now one thing to note here is even though these areas are getting completed before and they look lighter green, implying that they need to be done before these ones, that's actually because they are a predecessor of these coal areas now. So even though these parts are a little darker, because once we actually get down through this coal, we can see now, again, they are getting completed a bit before they need to be. We can start to see some of the complexities arise when we factor in that there could be multiple equipment in this, or our dependencies could be intertwined in such ways that actually create this. It's just a nice visual representation of different ways that we can understand, are our equipment mining this as late as possible? Is it too soon? Is it too late? And we can represent that visually.